TB is how many mils?
500.
500. That's quiet, passive breathing. Not forcing air in, not forcing air out. Forced air in is IRV. Forced inhalation is IRV. Why is it less for females than for males?
Size.
Size, yeah. Forced exhalation is ERV. We'll get to ERV in just a moment. And this bracket here on the far left is TB, IRV, and ERV. Those three things added together make up what? BC, good, vital capacity. So BC is the bracket on the far left. TB's in the middle? TB's in the middle, there's a little tiny one there. And this bracket over here on the far right is IC. IC stands for inspiratory capacity, and that's the next one on our list as well. Inspiratory capacity is how much air you can forcibly inhale. You'll notice there's two things included here. It's not just tidal volume, it's also the IRV added to it. If you're talking about a female, we're talking about 500 mils of air exchangeable during tidal volume. How much air can a female typically force in? About 2,100, right? So if you add those two together, 500 plus 2,100, IC for a typical female may be around 2,600 milliliters of air, or 2.6 liters of air. We've already labeled ERV, but what is that actually, we know it's expiratory reserve volume, but what are you actually doing during ERV? Forcibly exhaling, good. Notice the volume there is around 1,200 mils for both males and females. Just for a moment, go back and look at IRV. Females can force in around 2,100, males can force in around, say, 3,200. Why is that volume that you can force out roughly half of what you can pull in?
Because you have a residual volume remaining.
Good.
So your lungs don't collapse.
Exactly. You've got residual volume in there. You've got air that stays in the lungs to continue gas exchange. So, of course, you don't want your lungs to collapse by forcing all of that air out. So some air stays for gas exchange, and also so those lungs don't collapse. What's that, the ERV, the last question?
The residual volume, I think that's what.
Oh yeah, I'm not there yet.
Did you say that IC was the air that will be forced?
It's partly forcibly inhaled, it's also the tidal volume added to it. Okay. Okay, so that does take us to residual volume, that is RV. And on your worksheet here, this very bottom one is RV. You'll notice that there is no exchanging of gases going on during RV. Let me reword that. You're not moving air in and out of your lungs during RV. This is air that actually stays inside your lungs, not just to keep them inflated, but also to keep the gas exchange process going. So notice the number. It's approximately 1,200 milliliters of air. If you add that to what you can forcibly exhale, which is also 1,200, now you're getting approximately what a person can, on average, do during inhalation. Let me say that one more time. Residual volume is approximately 1,200. ERV is approximately 1,200, right? Add those two together, you get approximately 2,400. Go to the top of the graph. on average, females can force in 2,100, males can force in around 3,200, and give or take about 2,400 on average for any given person. Now you can see that that number up top approximately equals the two numbers added together on the bottom. So now you can see why we can't force out all that air. Half of it is in fact left in our lungs to continue the gas exchange and to leave the lungs intact so they don't collapse. So that residual volume is what is not exchangeable air. It's actually staying in the lungs to keep them inflated. The last link is not on the graph here, but you'll notice it is called the dead space volume. Last one is called the dead space volume. This is somewhere in the respiratory tract, perhaps in the primary, secondary, or tertiary bronchi, maybe in the bronchioles, but it doesn't reach the alveoli for gas exchange. So we count this air because it's helping to keep your lungs inflated. However, it's not actually contributing anything for gas exchange. It's a really small number. It's about 150 mils. Don't worry about knowing the volume for that one, so I didn't bold that number for you. You can see in this picture, this is a real printout of a spirometry reading. So you can see the respiratory graphs actually show normal breathing here in the middle. This is tidal volume. What is this part going up? That's the IRV. What did this person now do? ERV, forced it out. And then now they're starting to go back to resuming their breathing, their tidal volume breathing again. So just kind of an idea of how this stuff actually looks on a real printout. You've done some lab, right?
The volumes we did, but not the graphs.
Okay, so the graph is the only thing that's brand spanking new. Okay. All right. Any questions on 81?
On the bottom of the graph,
Yes.
to the left-hand side.
Okay.
Is that ELV? No.
This one down here is RV.
Oh,
Yeah, that's RV.
So we need the name and the volume, right?
Name and the volume, yeah. Alright, so what I wanted to tell you about was on getbodysmart.com there is a little bit of extra help, and this is kind of funny to read here. They do a physiological tutorial on pulmonary ventilation. That's pressure, volume changes, inhalation, exhalation. So if this doesn't ring your bell, try getbodysmart.com and see how that works for you. This is a free website. All you have to do is just type in getbodysmart.com, and then you'll have to look for the respiratory system and click on their tutorial there for the physiology. The second thing that they tutor you in is transport and exchange of respiratory gases. This is going to be our topic for quite likely the first 30 minutes in here on Thursday. This is something that I want to cover in one sitting because it's not going to do us a lot of good if we start it and then have to go back and redo it again Thursday. Try out the respiratory gas exchange stuff on there. They also have information on here about gas exchange and the process of loading and unloading and transporting oxygen and CO2. I'm also going to post for you up on D2L a couple of animations. Again, these are unfortunately flashed animations, so you may have to open them in your web browser or look for a viewer or a player so that you can look at these. But there's two animations. There's one on gas exchange and another one that's going to help you directly with page 82, and that's information on partial pressure. Page 82 is partial pressures. Page 83 is going to be transport of oxygen. And then, of course, page 84 talks about affinity and transport of oxygen and CO2 in a little more detail. This concept we're getting ready to do is the heavy-duty part of Chapter 21. So it's something you want to make sure that you spend a little time previewing today, tomorrow, in preparation for Thursday. That way we can make the best use of our time in looking at these kinds of processes. So yeah, these upcoming 4 or so pages, that's really going to be where the brunt of the meat of this chapter comes from. Alright, so got a couple of things for you to do between now and Thursday. Check out the IT10, check out Get Body Smart. I'll post these animations for you after class. Do y'all have any questions for today? See you Thursday.